right? So version 1 is I don't bother about what is in the vehicle, I'll just drive it. Version 2 is a person who understands a little bit about the internals of the vehicle so that they can use it better. Now, which version do you think is a better driver? Version 1 or version 2? Put which version in the chat. Version 1 or version 2? On the chat, everybody. Okay, exactly. So you all have to be version 2, and this is my variation of telling you becoming the version 2 of people using generative AI. So we'll try to understand how does it work on the internal. Okay, so again, it's a simple definition, no technical jargon. It is an artificial intelligence that creates content, say text, images, or videos. That's all. And generative AI is nothing but artificial intelligence that can generate text, images, videos, etc. Okay. The rest of the thing, don't worry. If you are understanding this much, you have understood what generative AI is. Now, little broad definitions of generative AI. First, we have artificial intelligence. Now, artificial intelligence is a field which is determined to build systems which mimic human intelligence. Okay. Now, I say this definition of mimic human intelligence because the human intelligence benchmarks have kept changing over the years. In the 1990s, it was said that if a computer bet a human at chess, then it is supposed to be intelligent. We have achieved good artificial
Recording in
intelligence.
progress.
Okay, you are almost there. Then you decided that, you know what, okay, that is too low a benchmark. I want to go above. I want a system that can beat humans at Jeopardy. For those of you who don't know, Jeopardy is a game wherein people are given answers and they have to guess the question that led to the answer. Okay, for example, the answer supplied to the team is Delhi. Then you have to supply the question, what is the capital of India, etc., which could make the most possible question that gave the answer. Artificial intelligence at that time was not so good at it. Then in the early 2000s, mid 2000s, artificial intelligence even bet that. Then they said, no, I think the most complex human playable game is called AlphaGo. I want computers to beat AlphaGo. That also has been achieved. Then they said, you know what? I want Turing test. That means if I'm having a conversation, on the other side, a human or a system both are chatting, right? If I'm unable to distinguish between a human and the system, then there is artificial intelligence. That also we have achieved. So the definition keeps shifting. Okay, but you can understand that artificial intelligence is trying to build a system that can mimic human intelligence, and this definition keeps changing every decade or so. Under artificial intelligence is pattern recognition, systems that learn from data. Now, what do you mean by that? Imagine you are going on Amazon and doing shopping. Once you add something to the cart, do you see the suggestions? You can also add this, you can also add this. Similarly, when you're watching Netflix, you just finished a movie, again, suggestions pop up. You might like this, you might like this. How many of you have seen this in your Netflix, Amazon, any of the systems? All of you have seen that, right? Awesome. So for those who have seen this, that is exactly what pattern recognition does, which is it learns from your previous behavior and predicts your future behavior. Okay. Think of any social media short form content. The more you watch a video, more of that video keeps getting recommended. That is pattern recognition. Okay, that is the next level, which is also called machine learning. Now, beyond Amazon and Netflix, sometimes when you are uploading your photo, that you are recognized inside the photo and it marks you that you are present over there. Or surveillance. If you are trying to track somebody, you can see that surveillance videos are able to track you in a crowd of people. Most of the movies kind of feature a scene around that. How many of you have seen that? That your photo is recognized, everything is tracked, surveillance wise, etc. Right? That is exactly how neural networks work. Okay, so because that is kind of neural networks, that is exactly telling you how it can recognize your photograph, etc. So this is a little more complex, where it tries to mimic how human brain looks at data, and this is something called neural networks, which is meant also called deep learning, meant for deeper image recognition and tracking. Then last comes your large language models, which is a subset of deep learning, wherein it can generate text, image, and videos. Okay. Artificial intelligence, broad, trying to mimic human intelligence. Next comes pattern recognition, which is looking at data, identify patterns, and predict your future behavior. Neural networks is going deeper into predicting patterns, but on a harder data set, harder problems like real time tracking. Then comes large language models, which can create text, images, etc. So this is in a nutshell the entire world of generative AI, right from artificial intelligence to the deepest of generative AI. So we are not going to study about AI, ML, or DL or deep learning. We are going to maintain focus only on the large language models. Okay, so in large language models, these are the generative AI subset, which is primarily focused on language related tasks. Okay, if you are understanding this much, it is clear. Folks, are you able to follow? Is my pace okay? Are you able to understand clearly or not? Just a pulse check before I move ahead. Okay, thank you. So I see that around 85% of you are good with this. So I will continue with the same pace, etc. People who want me to go slow or people who want me to go fast, you have to keep up with me and be available with me throughout. Don't worry, it will get a little more this thing. If some people feel that this is something I already know, I am trying to take people who don't know anything, try to get forward. Okay, so now we will get into some interesting internals of how ChatGPT works, wherein you can put an input inside ChatGPT and you get magically an output. Okay, now I am using ChatGPT as a general noun. I can think of it as Claude or I can think of it as Gemini. I can think of it as any other app. Okay, so let me first show that. Maybe I will open ChatGPT itself. Okay, and let me ask this little prompt. Explain large language models to me like I am 5 years old. Okay, so I'm asking explain large language model to me like I'm 5 years old, and this is what it tells me. Imagine you have a very smart parrot, a parrot that has read lots and lots of books, stories, websites, homework answers, emails, and conversations. When you ask it something, it does not think exactly like a human. Instead, it thinks, when people say words like this, what words usually come next? So, what does large language model mean? Large is it has learned from a huge amount of text. Language, it works with words. Model, it has a computer brain that finds patterns. So, for example, when I say the cat is drinking dash, the model guesses milk because it has seen sentences like that many times. It has seen sentences where cat drinks milk has been seen multiple number of times. Okay, so it has just understood things, right? For example, think of autocomplete on your phone. I am going to the, it will predict store because that is most number of times you are saying I am going to the store overall or I'm going to office based on your work overall. So that is how large language models work. This is the query and this is the response. Now I will go a little bit deeper into the internals and explain what is happening. So let us assume that I have given this exact same prompt, explain large language models to me like I am 5 years old. I am trying to explain this clearly. So at that point in time, the very first step I'll do is something called tokenization. So what is tokenization? Okay, imagine you are a chef. Okay, now if you are a chef and suppose you are trying to make something with pumpkin, do you use the pumpkin as it is whole or do you cut it into small pieces? Let me know in the chat. Cut into small pieces or use it whole? Let me know how do you guys think. What does a chef do? Absolutely. The chef cuts it into very small pieces. That is exactly what your model is doing. It takes your large sentence and is cutting it into smaller pieces. Okay, so when I say explain large language models to me like I'm 5 years old, it is trying to cut the sentences into smaller pieces. Another way to look at it is Lego. Lego consists of smaller pieces brought together. So I have brought together a Lego structure. The model breaks it into small pieces to understand better. After breaking it up into small pieces, next thing what it does is something called embeddings. Okay. Now, what is embeddings? Very, very simple. I'll not complicate with everything, etc. Like how humans understand English, computers understand mathematics. So that is the language computer understands. Now imagine that you are talking to a French person. Okay, so whatever words you say, you have to translate it into French for the French person to understand. Similarly, your computer can understand mathematics. So whatever English you have given, it has to be translated into mathematics for the computer to understand. So translating your words into a language that the computer can understand is the process of embeddings. Think of it like a map. Okay, think of it like a map, like a GPS. Now when you think of GPS, you will think of places like Eiffel Tower. Okay, you will think of places like Statue of Liberty. You will think of places like Red Fort. Okay, now from the GPS point of view, how does it remember these places? Can anybody tell me how does a GPS remember the places given? Red Fort, Eiffel Tower, Statue of Liberty. Exactly. Everybody is getting it right. It is the coordinates, right? That latitude and the longitude coordinates. Now, as a human, if you give me a coordinate, can I understand what the coordinates, what place I'm referring to? Can I understand yes or no in terms of coordinates? Absolutely not. Because I don't remember that. Unless you tell me Statue of Liberty, I won't understand everything. So think of this embeddings to be the process of transforming the words into coordinates. And the best part is similar meaning words become neighbors. Okay, that means if I'm looking at words like founders, startups, fundraising, VC, they live in the same neighborhood. Then I say student, exams, right? They live in another same neighborhood. Okay, so these are people who are living in the same neighborhood overall. That is exactly what I am trying to do. Okay, so I have got embeddings, which is now converting my words into coordinates with similar meaning words existing in the same neighborhood. The next step is where the magic happens. Okay, the model focuses on the most important parts of the text. That means it is now trying to understand that from this entire sentence, what is the important words that will change my answer or supposedly change my answer. Okay, now think of it like you are going to a movie theater and let us suppose your seat is F12, right? And it is dark. So what you do is you roughly know the architecture of the movie theater where there is A, B, C, D, E, F. You don't start searching from A. You directly, approximately where F is, and you shine a torch on the F seat to exactly find that F12 seat. So F is the important part of the description, which helps you to focus on that particular thing. Similarly, there are some words which allow you to focus on the most important words, and that is what self-attention is. Large language models and like I'm 5 years are important parts which will change the answer. For example, if you think of removing that word, if your answer changes, that is an important word. And this is like shining a torch on the important word so that the model can focus on them. That is self-attention. Then you make predictions. Okay, let us take a simple exercise. Let us assume that the sentence is: imagine you have a super smart robot friend who read every dash. What is the most likely word? Is it book or is it bank? Let me know in the chat. Is it book or is it bank? Okay, exactly. Everybody is saying book. That means you are looking at book and you are, because you have read many things where you said read every book comes later. So it makes the prediction that book is the most probable word that is present, and word by word you try to predict. And then finally, you have the complete response with bullet points or paragraphs or anything that happens so that you can understand it really well. So this is like converting your coordinates back into words and giving you the sentence. And that is where a sentence like: imagine you have a super smart robot friend who has read every book, story, and conversation ever written. When you ask it a question, it looks through all the words it has learned and finds the best answer just like magic. So this is the 5-step process. Tokenization, chopping up your sentence into little words. Embedding, converting the words into mathematical constructs or coordinates so that similar words live in similar neighborhoods like a GPS. Then transformer, you can look at the exact content and you figure out what is the right words where you need to focus upon the relevant important parts which can potentially change the answer. Prediction, then you try to predict which word comes next and you try to generate the response by iteratively predicting the words. Folks, are you now clear on an intuitive level how generative AI kind of works underneath? Having a good understanding right now? Folks, yes? Okay, awesome. Let's move on. So this is exactly how generative AI works, and you can pat yourselves on the back because you are better than 95% of the folks out there who don't know how it works in the backend. Okay, good job. Now, let us try to understand how to talk to these models in the best possible manner. So till now we understood the internals. Now we'll get into understanding the driving part of it. How do you start the bike? How do you, release the clutch? Or, how do you kind of set it up into position so that you are driving it smoothly? It could be a bike, it could be a car, it could be anything. How do you drive it smoothly without any jerks? That is what you're going to learn in the next possible thing. Now, there is a lot of conversation around prompting. Okay, people say there are multiple prompting techniques out there. Okay, but what people miss out is you cannot learn prompt engineering unless you learn something even more important, which is called context engineering. Okay, prompt engineering is giving better instructions. Okay, so the better instructions is like, take your vehicle, turn it on, start with the battery. If the battery is not allowing the vehicle to start, give it a kick or two, etc. Okay, so that is like giving the better instructions out there. Now, context engineering is little bit different, where you are trying to give AI everything a smart human would require. So context engineering in terms of bike is, this bike is a Yamaha RTX series, which has got pretty good battery. So you can directly use battery to start it. You don't require to use a kick. Are you understanding the difference between prompting and context? Prompting is instruction giving. context is giving information that will help you use the tool better. Okay, folks, are we clear over here? Because this is a very important point. So if you are clear, we will be able to go further and go deeper into this, right? So just to give you a little more understanding in another example.